Welcome students. My last video I already told you that I will explain the Kepler's law and the planetary motions. So today I have drawn the figures for you due to the lack of time. Now let me explain what the Kepler's law and what are the three laws of Kepler's for planetary motions. Okay, the first law is the laws of the number 1. Here I am writing laws of orbit. Second law is laws of areas. Laws of areas. And third law is laws of period. Law of period. Okay. Now, what is law of orbit? See, Kepler's the famous scientist, he told that all the planets who are revolving the sun, they are revolving the sun in an elliptical orbit. Okay, this is the first law. Law of orbit means all the planets revolving sun in an elliptical orbit, keeping sun as one of the focus. In the elliptical shapes, there are two foci. Here one, here one. So the keeping sun in one place of the focus, all the planets just revolve round the sun in an elliptical orbit, and this is the first law of orbit given by the famous scientist Kepler. Clear? Second law is a law of area. What is the area? See, since the path is not circular, so the velocity of the planet throughout the elliptical orbit is not constant. If the orbit is circular, then suppose if it is a circular, then the velocity of the motions will be constant, but our speed of the planet will be constant if the orbit is circular. But it is not circular, since it is an orbit, elliptical orbit, so the speed of the planet is not constant. But the time, see here, but the line joining, suppose this is a planet, suppose here one planet is here, so the line joining the center of the sun and the planet, suppose it is Earth. Okay, so the line joining the center of the sun and the planet, or suppose here I am taking an example with Earth, then this line will sweep equal distance, equal areas, this much. Suppose this one t time t1, so this is time t2, this is time t3. Okay, now DSC, this area, suppose by this line, this one just sweeps here, from here to here, so this line is coming up to here. Then this area sweeps by this line by the time t1. Clear? Here, suppose the positions of the planet is here. Now, this is the line joining the center of the planet and the sun. That this line by the time t2, it sweeps our area, this one. Clear? This one from here to there by the time t2. Now, if the positions of the planet is here, this line here, suppose this line sweeps coming up to here. Now it covers an area this much. Now what Kepler told, that if T1 equals to T2 equals to T3 means if the time, suppose it is 1 second. If 1 second, 1 second, 1 second. If the time is equal, means T1 equals to T2 to T3, then Kepler's told that the area of this one equals to area of this one equals to area of this one. Okay, this is called the law of area. This is called the law of areas. So Kepler's second law, what he told, that though the speed of the planets revolving the sun is not constant, but the areas, the line joining the sun and the center of the planet, this line sweeps equal area in equal interval of time. Means if T1 equals to T2 equals to T3, these times all are equal, then the area of this one is equals to area of this one is equals to area of this one. This is Kepler's second law, which is called law of areas. Clear? This is the second law. The third law is called, that means, now see, if a planet is moving, suppose here, now moving here up to here, now coming to this position, suppose it's taking the time t, and what is called to revolve the sun, the time taken by the planet to revolve once is called the time period t. That means time taken by the planet to cover one elliptical orbit. That means from here to here coming back, whatever the time taken, suppose if this is t, this is called the time period of the respective planet. Now, and Kepler's third law is telling law of periods, what he told, and the suppose this one, the distance of the r. See, this is the distance between the centers of the sun and the planet. Suppose I am taking here Earth, then he told, suppose if the planet is here, then it is R1. If the planet is here, then suppose it is R2. If the planet is here coming, then it's R3. So that is, suppose R1 plus R2 plus R3 by 3, that is, suppose it is R. This is the mean radius or mean distance, better to say, mean distance of the line. That means the line, which line? Line joining the earth, the planet and the sun. The mean distance of this planet, because the planets during the elliptical orbits is, the R is not equal all the time. Sometimes this one is long, sometimes short, sometimes medium. So that's why he told that mean distance of the line joining the sun and the earth, this is called R. And the what is called, the T is the time period, means time taken by the planet to revolve the sun once. This is called the time period. Clear? What Kepler's given relations between these two, he told that T square proportional to R cube, means the square of time periods is proportional to the cube of the distance. Which distance? The distance from the sun and the planet. Okay, it is better to say the mean distance. Okay, that means you have to throughout his path, the several distance taking, several that mean taken, as I have told already, R1 plus R2 R3 by 3, but several more than, suppose n times they have taken the distance, and R1, R2, R2 up to the n, and by divide by n, that is getting the mean distance R, And that one he told, this is the third law of Kepler's, that time period square proportional to the distance q. Clear? This is the third law, and this is called law of period, where and t square you can write k r q, where k is a constant. As now you are seeing, since k is a constant, so what relations we are getting? As the distance r will increase, the time period also increase. Suppose the planets, suppose you know our 8 planets are there. So which are the nearest? R is less, their time period is also less. The furthest, the farthest the planets whose distance from the sun is more, then this their time period also simultaneously will increase. Because by this relations, the relations giving the law of periods, this relations giving by the Kepler's, and this is called the law of periods. Law of periods. Okay. So now these three laws, law of orbit, laws of areas, and laws of periods, by these three laws, Kepler's tried to explain the planetary motions of the sun or all the universe, all the planets in the universe, how they are moving or revolving to each other, and that is not the, see, the planets revolves the sun, and suns revolves in the galaxy, and galaxy revolves to relative to one another. One galaxy revolves to another galaxy. In this way, throughout the universe, all the objects are moving, and moving. Why? Because due to of the gravitations. Gravitations means the attractions between the two objects. Okay, this is the main base of the gravitations. Due to the gravitations, through all the objects in the universe, they are moving or they are in motion in a systematic way. Okay, my next video I'll explain you the rest of the incident of based on gravitations. Thank you.